Okay, in this problem, they give us that the outside temperature over a day can be modeled as a sinusoidal function. They give us that the high temperature of the day is 87. I'll mark that here. The low temperature is 63. They also tell us that this low temperature of 63 occurs at 5 a.m. So if we consider the vertical axis as the temperature, D, in terms of the input variable t for time, put a t down here on the horizontal axis, what we can do is plot the dot 5, 63, because they said at 5 a.m. that time, the temperature would be 63 degrees Fahrenheit. So I guess that's why they chose capital D as an output variable, because these are in degrees, and I'm assuming that it is Fahrenheit. The only way to get this 5 to represent 5 a.m. if you let t be the number of hours after midnight, because 5 a.m. is 5 hours after midnight. To be able to find the equation they're asking for, I need at least one more point. For example, I can assume that the reason they're using a sinusoidal function is that they realize that temperature swings are caused by the Earth rotating, which takes 24 hours. That's why we have 24 hours in a day. This means if I add 24 hours to this 5 hours after midnight, we would be 29. And I know since there's 24 hours difference between these two time values, that we can predict that we'd get the next low temperature again at 5 a.m. the next day. And this gives me some idea of what the graph is going to look like. Since I'm assuming that the temperature is sinusoidal, I need to fit a graph that looks like this. What we just found out was what the two low points are. So since we know the two low points, I can say that the graph is probably going to look like this part right here that I'm shading in blue. And it's pretty clear that the high point, the highest temperature, 87, would be in the middle of these two dots, visually somewhere here. And since there's 24 hours total in this cycle, I can assume the high temperature would happen halfway through, which would be 12 hours after this point here. So that would be 17. And I can sketch my graph in here from this point to this point to this point, much like I did over here in this picture. And that's about as good as it's going to get graphing by hand. Now that I have my low and my high temperatures, I can average the two to find the midline, which is the value of C in my general model. I haven't decided whether in this blank here I'm going to use sine, cosine, or if A comes out to be negative, you could think of it as you'd be graphing negative sine or the shape of negative cosine. Once I decide on what I want to put here, that will decide on the shift D that I must use. So there's infinitely many correct answers to this question. I can use any of these four models I want, and depending on which one I pick, will only be correct if I adjust the D value accordingly. But let's just start with finding C first. Then I will find the value of A and then B, because that seems to be the easier part of the problem. So step one is to find the value for the midline. That's find C. This can always be found by averaging the low and the high temperatures. My low is 63. My high temperature, if you go up and look, was 87. And the middle of those two numbers, the midline, would be found by just adding those and dividing by 2. Doing that, I get 75 degrees Fahrenheit. That would be your average temperature throughout the day. So that's the number that's going to go in for C. C is going to be 75. That represents the average temperature. I can put it in dotted. That would be the midline. Y equals 75 degrees would be the equation for the horizontal line, which we call the midline. Once you graph the midline, it's very easy to find the value of A, the amplitude, because the amplitude is just the maximum deviation between the midline and the graph. So that would be right here. The graph goes as high as 87, and to figure out how much deviation there is from 87 to 75, you simply subtract. So finding the amplitude is very easy once you find the midline. You just take the high point and subtract the midline. So step 2 is to find A. That can be accomplished by taking the high and subtracting the midline. This isn't the only way to do it, but that's one way. The high was 87. The midline was 75. And if you subtract that, you get 12. So there's 12 units deviation above the midline. If you took 75 and added 12, you'd get 87. If you took 75 and subtracted 12 to see how low the graph goes, since there's 12 units of deviation here, you'd see the low temperature is 63. 75 subtract 12 is indeed 63. So in my general model for A, I will write 12 for the value of A, although I haven't decided whether A is going to be positive or negative yet. That comes later when I decide what function to use. But what I can find now would be the B value. So to find B, since we're given a graph, the graph will tell me the period, and I can just use this formula that the B value in the equation would be 2 pi over whatever the period is in the graph. I don't have to look at the graph. I remember the story that the assumption is that since we're talking about temperature, that the low and high temperatures would be in a cycle that's 24 hours long, because that's how long it takes for the Earth to rotate, and that's what causes the high and low temperatures. 2/24 can be simplified as 1/12. So I'm going to say that the B value for the equation is pi over 12. So here's my B value right here, and I would just put in pi over 12 in its place. So the B value and the midline and the amplitude have to be those three values. I have no choice there. But as I said before, I have lots of choices of what model I can use. So if you remember the shape of all of these models, this is the important part. You realize that if you're going to use the sine function, then you need to find out where in my wave the graph starts on the midline and does this shape here. If you were going to pick a part of the graph that starts on the midline and does the valley first, say, and then the mountain, rather than the mountain first, then the valley, you would use negative sine. If you picked a part of the graph that starts at the high point and does this shape, you would be using cosine. Lastly, if you were to pick a part of the graph that starts below the midline and does sort of the upside down version of that, that would be negative cosine. You can use any of these four. Now, if you look at which one fits best on my graph, it's negative cosine. It starts at the low. Just by the way I graphed this, because they gave me the time of day that was the low, it makes it convenient to use negative cosine since that's what I have here. But please realize that this graph keeps doing this forever. You have a full wave to the right forever and to the left forever. So you can use sine, cosine, negative cosine. I'm going to use negative cosine to get the answer first. But I hope that you continue to watch the video so that you can see that there's other choices. And this way, if you were to read some other people's work, you would need to understand how they came up with their model. So since someone else can choose any of these four choices here, and you're reading what they wrote, it would be important for you to realize where they came up with that model. So for example, if I was to use negative cosine, so we have A is negative. That doesn't mean amplitude is negative. Amplitude is always positive. So the amplitude would be 12, but A is a negative number. Remember, A is not the amplitude, right? The absolute value of A is the amplitude. So the idea is because my A value is negative 12, my amplitude comes out to be 12. But A itself can be negative. So I'm using negative cosine. And now, like I said before, because of my choice here, negative cosine, I can adjust the D value accordingly. Why do I even have to have a D value? Why can't I just have x minus 0 here? Because of this. If you don't have a D value, or more precisely, if D is 0, what your graph would look like is you would get the low temperature of 63 at 0. So I failed to put that in all of my models here. But because there's no shift, right? If you want, you could fill in an x minus 0 in all of these. I was assuming that there was no shift left or right by not subtracting or adding here on the input variable. What that means is I was assuming that this happened at x equals 0, or in our case, we're using the input variable t, that these are the shapes you'd get if you use these exact models without shifting left or right, and that would happen at t equals 0. So we're using negative cosine down here, so focus your attention on that. So notice, without shifting left or right, you get the low point at time 0. We don't want that. We want the low point at time equals 5 a.m. because that's what was given in the problem. So if we were to graph this without shifting, our low point would be here at t equals 0, and the graph would go like this. Our graph would always be 5 units to the left of the graph that we wanted. So the idea is to get from the green graph, which is the graph of what we'd get if we graph this with d being 0, to the graph that we want, you'd have to shift the green graph to the right 5 units. So that being said, I would just put a 5 there for D, and my full model would be y equals negative 12 cosine pi over 12. D is 5. If you remember correctly, subtracting on the inside of the parentheses moves to the right. And this would be one correct way of writing the problem. Now, if you're doing this in our homework management system, you might notice that they tend to put the 75 to the left. So instead of having plus C at the end, they do C plus at the beginning. Because addition is commutative, you can do that. So you might see in our homework management system in the show answer, they put the 75 in front. So I really urge you to keep watching the video now, because I want to do the same thing now, but offer a different answer. So to show you that you can use other equations, I'm just going to pick cosine this time. In fact, I will pick positive cosine. So note that our work for the value of A, B, and C don't change. The amplitude is still 12. The B value is still pi over 12. And our midline is still 75. But rather than using negative cosine this time, suppose I wanted to use regular cosine. So my A value will be 12, and I put a cosine here. So I said I could do that as long as I adjust my B value accordingly. So if you remember, if you're using cosine, cosine is the function that at time 0, or whatever your input variable is, whenever that's 0, without shifting left or right, the input variable being 0 is the place where you get your high point. So if you look at where our high point is now, the high point is at 17. So what happens is if you don't shift left to right and you use cosine, you're going to get your high point at t equals 0. And since I adjusted all the other letters correctly, you're going to get this shape. It's just going to be 17 units too far to the left. So I need to shift my graph 17 units to the right. So right 17, because you'd be getting the high point at t equals 0, and we need it to be at 17. So again, this is because I put a cosine here, and it happens to be that the cosine function starts, if you will, or at least its behavior at t equals 0 is at the high point. In our case, that's 87 degrees. So it would be correct if I was to put a minus 17 in here, but change negative cosine to regular cosine. This is just one way to do it. Another one that would be very easy for me to see is I see the sine function in here. Remember what the sine function does. The sine function starts on the midline. When I say start, I really mean whenever your input's at 0. Starts on the midline, does this sort of mountain first, then the valley. And I see that part of the wave. Remember, all 4 of these pictures are in the wave somewhere. I see that sine shape starting on the midline and doing the mountain first, starting right here on the midline, doing the mountain first and then the valley here. I see that shape. Probably would be better if I use my highlighter. So I see the shape of sine where I am highlighting in green. If you just focused your attention on this part of the wave here, that is the shape of sine. Now, if we didn't shift left to right, of course, we'd be starting on the midline, right? That's what the sine function does. At time 0, it starts on the midline and does the mountain first, then the valley. So the idea is we'd be too far to the left. We'd have to shift our graph to the right. How far we'd have to shift to the right is a little bit of a mystery here, but I'm assuming that hits the midline directly between t equals 5 and t equals 17. So if you just average those two numbers, you'd get the middle of 5 and 17. I believe that is 11. So if you use the sine function, you would need to shift 11 units to the right to get your graph to start on the midline instead of at 0 to start at 11. So another way of getting a right answer, remember you have to keep all of these other numbers the same. A still has to be 12. B is going to be pi over 12, right? The time that it takes the Earth to rotate is not going to change depending on what model I use. The average temperature is going to be 75 no matter what. And the temperature deviation from the midline is 12 no matter what. So if I was to use a sine function now, it looks like I have to shift to the right 11, so I'll put a minus 11 in there. You get the idea. I'm going to stop the video here, but suffice it to say, the only one I didn't do is negative sine. If you're going to use negative sine, you'd be picking the part of the wave that starts on the midline but does the valley first, then the mountain. Using negative sine, I'd focus my attention on this point right here, because that would be the one that starts on the midline and does the valley first and then the mountain. And you'd be finding the midline, the middle of 17 and 29, to figure out how far you'd have to shift your graph to the right so that you'd be starting that behavior at that number rather than at 0. So hopefully that doesn't confuse you, but I did want to show that the choice of whether you use sine, cosine, negative cosine really is arbitrary. Use what you want. I always use what's convenient, but you always have to adjust the value of d so that it will work